Okay, frequently in an algebra class or geometry class, you'll be given an assignment where they ask you to find the distance between 2 points, and they say use the distance formula. And you usually won't see them on a graph like this. In fact, usually what you see is something like this. Just a statement. Find the distance between 2, 5 and 9, 15 on the graph. And then kind of this mysterious wording here, use the Pythagorean distance formula. And so let me unpack that for you a little bit. I've taken those 2 points, 2, 5 and 9, 15, and I stuck them on a graph. So 2, 5 right here and 9, 15 there. And what I want to do is point something out here. If I draw a line straight over here from the lower point to directly above the upper point, okay, I can easily find that length. In fact, I wouldn't even have to count. I could just say, you know, since this point right here is 2 to the right, and this point is 9 to the right, then this distance is just going to be 9 minus 2, or 7. Okay. Well, I can do the same kind of thing with this distance right here. I can say, look, I can figure out the length of that line or segment without even counting. I can just say, look, this one's at a height of 15. This one's at a height of 5. So I can subtract those and get 10. So now I know this length is 7 and that length is 10. Well, isn't this a right triangle? Because the x-axis and the y-axis are at right angles to each other. So this is a right triangle. In other words, I can use those two short sides, 7 and 10, as the short sides of a right triangle and square each of them, add them together, and that should get me this distance, oftentimes we call it c, squared. So if I square root this, then I'll just get what c is. So what I found is all I have to do is figure out how long is this horizontal side of the right triangle, how long is the vertical side of the right triangle, and then I've got two short sides of a right triangle. Well, to get that horizontal side, all I did, let me do this in purple here, to get this purple line, I subtracted the x coordinates. In other words, the numbers I underlined in purple. To get the green number, the vertical side, I subtracted the vertical coordinates, the 15 and the 5. So what I can do, if you give me some set of points here, say 3, 11, and 5, 15, I'm erasing my previous work from a previous attempt at this video, instead of putting these things on the graph and counting lines and that kind of stuff, I can say, look, the vertical side of the right triangle is going to be 19 minus 11, so 8. The horizontal side is going to be 5 minus 3, or 2. Now I've got two short sides of a right triangle. I can find the long side. So I'll write 8 squared plus 2 squared, and then I'll square root that to get what this distance is. So it doesn't matter, honestly, how complicated looking the work is. Okay, if they give me 2 points and I need to find the distance between them, all I need to do is subtract the x coordinates, 9 minus negative 2, okay, to get the horizontal side of the right triangle, and the vertical coordinates, negative 3 minus 5, to get the length of the vertical side of the right triangle. And then I've got two numbers that I can square and add together and square root. Okay. Now, it might bother you that negative 3 minus 5 is negative 8, and that can't be the length of a side. No problem. If you did 5 minus negative 3, it'd be positive 8. Okay. But here's the thing. Whether it's negative 8 or positive 8, you're still going to get 64 when you square it. So honestly, it doesn't make a difference what direction you subtract those. So as long as you use the x coordinates subtracted and the y coordinates subtracted, and then square each of them, add them together, and square root, you're good to go. You've got the distance. So when you see something that says the Pythagorean distance formula, maybe right, they'll say, here's 2 points here, and then here's this giant formula that gives you the distance. And that's kind of ugly looking, but here's the deal. If you subtract the x coordinates, you get that number. Okay? If you subtract the y coordinates, you get that number. Okay? Then you square them, add them together, and square root just like you did before. So I really hate it when books will give you this giant formula and just say, here, plug all these numbers in, because it doesn't help you make sense. I like to visualize it first as a right triangle where the blue underlined part is the horizontal, oops, I should draw that in blue. The blue part is the horizontal length of a right triangle. The green part is the vertical length of a right triangle. And then you're simply finding the distance between those by doing the Pythagorean theorem. Okay, so that's what the Pythagorean distance formula really is. Okay.